Hi, good morning viewers. Today I am before you in your online coaching in mathematics in UG classes, TTC part 1, in which I am going to start the areas of some known and unknown curves. In the previous classes, we have taught how to trace the curve of unknown curves. Let us first of all we try to trace the areas of some known curves first. Let us first take the area of circle whose equation is x square plus y square is equal to a square. If we draw a circle and its both perpendicular diameters are taken as x-axis and y-axis, then we find that O, which is the point of intersection of both axes, that is origin, its coordinate is 0, 0, and the radius is A, and the point of intersection at x-axis is A0 and at y-axis is 0A. We see that the circle is equally divided in four equal segments on coordinate axis. We take the segment area of circle of first segment. We see that we can draw a perpendicular line which is of length y and its width is dx, and its area is y dx. For entire area we have to integrate y dx from limit 0 x is equal to 0 to a y dx, and whole area is multiplied by 4 because the whole circle is divided into 4 equal segments. Now area of circle, as we know that x square plus y square is equal to a square. In terms of y, it is root under a square minus x square into dx. Now we can integrate by putting x equal to a sin theta or a is equal to cos theta. We can integrate easily, and finally we can find its area is pi a square by 4 and multiplied by 4, that is pi a square. It will be the area of circle, we can easily find. Now let us come the area of ellipse. Area of ellipse, its x-axis is major axis and y-axis is minor axis. It is also divided into 4 equal segments. Its cutting on x-axis is A0 and cutting on y-axis is 0B. 0B, as equation of the ellipse is x square by a square plus y square b square is equal to 1. We take the first quadrant of ellipse. We see that if we draw a perpendicular line of length y with dx, its area is y dx, and we try to integrate y dx from limit 0 to a, and we can find the area as pi into ab by 4, and the whole area will be multiplied by 4, that is pi ab by 4 into 4, that is pi ab. Similarly, we can find the area of parabola y is equal to 4x bounded by its latus rectum x is equal to a. we have given the material with this delivering lecture under the links of both known and unknown curves. You can see easily. Okay. And y square 4ax is the equation of a parabola bounded by latus rectum, and we can easily find its area from integration 0 to a y dx. Y here y square equal to 4x, that is 2 root x dx, and after integration we can find easily its area. Viewers, now we come on the area of some unknown curves. We have taken one equation for finding the area is y square into a square minus x square is equal to x. Yes. First of all, we need to trace the curve. Point first, we see that the curve is of fourth degree. The curve is of fourth degree, and the even powers of y only is present. Even powers of x is not present. Only even powers of y is present. It means this curve is symmetric about x-axis only, not symmetric about y-axis. Second, this curve, easily we can see that this curve passes through the origin. When a curve passes through the origin, we need to find the equation of tangent at the origin, and it will be equating by the lowest term, and we can see that x-axis and y-axis are the tangents at the origin. Third point of, we see that where the curve cuts x-axis or y-axis, we can see that if by putting y is equal to 0, we see that the curve meets at, when by putting y is equal to 0 we find x is equal to 0, and by putting x is equal to 0 we find y to 0. It means that the curve meets x-axis and y-axis both at the origin. Next point is whether the curve has asymptotes or not. We can see that the curve is of fourth degree, and the term x2 and the variable x4 and y4 both absent. It means that there may be asymptotes parallel to x-axis or y-axis. Asymptote parallel to x-axis, we see that y becomes imaginary. So we cannot find asymptotes parallel to x-axis. But we can see that x is equal to a and x is equal to minus a are the asymptotes parallel to y-axis. On this basis, we draw the curves like this as given in figure in a given link, and when we try to find out its area, its limit is 0 to a multiplied by 2 y dx, and we find y from the equation dx, and after the integration we get result, the area. Dear viewers, if we need to find the length of these curves, we have to only replace area from length and under the integration y in place of y dx we put ds by dx into dx. ds means root under dx square plus dy square. By dx it means area of length is root under 1 plus dy by dx square into dx. If we differentiate y of given equation, we find dy dx, we put in the equation and we can get result of length. Today I am going to finish this lecture and I am waiting from all of you your query from us, from me, and I am trying to solve all of your problems as far as practicable. So thank you. I am going to end today's my lecture. Thank you. Thank you very much.